I've been going to Antarctica for almost 25 years now. And after looking at these polygons in the Transantarctic Mountains and recognizing that these sublimation type polygons only form where there's very, very cold conditions and no liquid meltwater, we started looking for these features elsewhere in the world and we couldn't find them. And then we started seeing some of the high-rise images coming in of Mars. And there we found them all over Mars. They're nearly identical to the sublimation polygons we find in Antarctica. And so we started taking our Antarctic field knowledge and applying it to Mars.
The dry valleys are one of the coldest, driest places on planet Earth, and so it's the best terrestrial analog that we have for the Martian surface. If we know that a flowing buried glacier makes these types of ridges in Antarctica, that if we see similar ridges on Mars, that might be there's buried glacial ice on the surface of Mars.
And so we started looking at images of Mars through satellite imagery. And in so doing, we saw that there's shallow buried ice on Mars. There were ancient glaciers expanding and retreating. So just as the case for the Earth, finding buried ice on Mars would be extremely important, not only in terms of reconstructing Mars' atmosphere, but these buried ice deposits. They're basically small niches that may harbor past life.
We do find more than just gas in the ice. Occasionally we do find little microbial life.
If you find buried ice, there's potential for past life on Mars, or even some sort of microbe locked up in the ancient ice.
That's been one of the interesting outgrowths of this research, is we started in Antarctica, and now I'm ending up in Mars. It's really incredible, actually.